Here we go. All right, guys, buckle up. We're gonna talk about the Smog systems. Hey, Moto buddies, what's up? This is Mike from Taco Moto Co. and Baja Taco Tours. Today I'm gonna give you an overview of the Smog systems that are on your bike. The world is not ending. Everybody is tripping balls, worried about these two little systems that the street legal bikes. If you have a plated motorcycle in the United States of America, the Environmental Protection Agency has gotten up in that biz, and they've given you two emission systems on your bike. And this is any machine, any of the machines, all of the Japanese bikes, the Austrian bikes, they all have some variant of the system. This is how KTM does it. And let me just say up front, if you have these two systems on your bike, you are not losing power or performance. There is no gain to be had. Let's be very clear. There's no gain to be had by removing these, and there's no loss by having them on. But that's not to say there are a couple of valid reasons why you might want to remove these, and so we'll cover that. And let me also be clear, these are mandated by United States federal law, and so if you tamper with or remove these systems, then your bike is technically no longer street legal for use in the United States. You may be in violation of state law, local law, federal law, and you have now made your bike into an off-road only race competition use machine, so know that up front. All right, so let's get into this. So why would you want to take and remove any of these two systems? First of all, reliability, and then removing a failure component, something on your bike that would fail, a failure point. And so let's just break these two down. You have, the first one is the SAS system, the secondary air system. That's the smog pump air injection system. These have been on engines, road-going vehicles, since it's like 66, I think, was when Chrysler introduced the first pump air injection system. So that's a positive pressure air system on the little single cylinder. And this you'll find these systems on lawnmower engines. Any type of generators have these now, so you'll find these on any internal combustion engine and then also on our motorcycles. So what we have on our bikes is a reed pedal pulse impulse system. These are aspirator system. This is an aspiration system that draws in air into the exhaust stream. So the exhaust, as it comes out of the engine, contains some unburned hydrocarbons, and so those are components of pollution and smog and ozone. And so one of the ways, methods to reduce that, is to burn those as they're exiting the engine at their hottest temperature at the exhaust valve, and then that combustion can complete itself through the header pipe and the mid pipe, and then even, depending on the fuel ratio, the mixture, even out through the muffler. And so when that happens, the thing that guys will, on the internet mechanics, what they'll say is get those systems off because they cause your bike to pop, deceleration popping, and that's the thing. That's actually legit. So one of the myths is that by removing it, you'll gain power, and that is a total myth. So the air injection system works by, you've got this device on the cylinder head. This is on the right-hand side up towards the cylinder head. This is right at the exhaust ports. So how this thing works is inside of this. So here's this little reed pedal aspirator right here. And this is the engine side, and then this is the fresh air side. And so negative pulse pressure pulls this reed open, and then it ingests a little gulp of fresh air. And so this negative pulse is created as the piston is on the exhaust stroke. So the piston is pushing up, piston's going up, the exhaust valve is open, and so there's positive pressure here on this side, which holds it closed. But as soon as the piston begins its downstroke to begin the intake stroke, there is a bit of valve overlap where the exhaust valve has yet to close, and it creates the down travel of the piston creates a little negative pressure, and that negative pressure pulse pulls this reed pedal open. A little gulp of fresh air goes into the exhaust stream, and that mixes with those unburned hydrocarbons, which are extremely hot right as they exit the exhaust valve, and that combustion, that completion of combustion, is the purpose of this system. And the backfire or the popping, the deceleration popping that you hear is the uncontrolled, unmanaged, and unmuffled explosion, random, uncontrolled explosion that's happening, that burning of that fuel in your exhaust pipe. So they're little mini backfires is what they are. It's just uncontrolled combustion. When it happens inside of the cylinder, you'll hear engine roar, you'll hear noise, but it's not exposed to ambient through the pipe. And so when it happens in the pipe, it's a different sound, and it's that popping sound. This only happens in deceleration or at idle. This is only, those negative pulses are only happening when you have these negative pressure pulses, and that's either at idle or on decel. Decel is when you hear the pop. Once you get to idle and the engine has burned all those, then this is opening at idle. As you're sitting there idling, this thing is pulsing itself, but it's such a low volume of hydrocarbons that are coming out at that point, there's no sound really. It's burning in the header pipe, but it's not at a sufficient level to create that sound. So this does nothing to the power. It just is a convenience item in that it takes away that decel popping sound. The other reason you might want to take this out is this is a failure point. If this little reed pedal were to stick open, you would have an exhaust leak. And I've seen this where something happens to this and now this pedal is just open all the time, and that allows a transfer between ambient air and then the exhaust port. So you just have an incredibly loud exhaust roar, and it comes out, that sound will come through here and then out this little, this is like a little air filter. This thing right here, all it is a little plastic chamber with a piece of foam stuck in there. So fresh air is coming into this and then going into the exhaust stream. We don't care that that air is dirty or not because it's going right out the tailpipe. But I mean, I think it's a good idea that they've put this little air filter on here. So if this failed, then you'd have this exhaust leak, and then it would just be sounding out here. And the foam on that particular bike, the foam insert melted. This is straight off the exhaust valve, and so it's incredibly hot. It didn't go on long enough to like do anything here. It didn't cause a fire. It didn't really damage any of this, but it melted out that foam. It made a really loud sound and then a weird smell as this thing melted. So that was the symptom on that guy's bike. So that's one reason to take this off, is this thing could fail and cause an exhaust leak. The other reason would be this has a profile that sticks out on your motor, and if you took a rock and broke this thing off and snapped any of this up in here, you'd have a full exhaust leak off your motor, and that could be potentially damaging because now you're going to be introducing cold air right at the hot exhaust valves, which will very likely warp them and damage them. So removing this to cure the decel pop, removing this to prevent potential trail failures, 100% valid. Removing this to add or change power, completely myth, total bogus. So that's the air injection system that you have on your bike. And another thing too, guys will ask all the time is, well, if I remove this, then what do I do about this hole in my cylinder head? Well, you can go and get a bolt. I mean, you could go to the hardware store and buy a bolt of the correct thread pitch and depth that would plug that. We sell a bolt kit that does that. You could also, I know guys will put some tape over this. They will fill this up with silicone, RTV. You could find a ball bearing that's the exact diameter, a little bigger, of this little rubber hose right here, and shove it in there. The idea would be if you kink off this air, then the pulse, the negative pressure in the cylinder will still be trying to pull this reed pedal open, but there's no fresh air available to be drawn in, and so effectively you've defeated this. So you can use any method you like and feel comfortable with, stopping the airflow or removing and capping this. So they're all valid, it's all equal, it does the same job. Obviously it's cleaner if you take this off. If you live in a state that has visual inspection of your bike, you might have an inspector who's keen to this and is aware that this should be on your bike and would be looking for it. And so if you live in one of those states, you more than likely will do well by, having it be intact but yet plugged. If you live in a state where that doesn't matter, my suggestion would be to remove this, because this component right here in an off-road situation is vulnerable to being broken off, and then you'll have that huge catastrophic exhaust leak. So just two different methods of dealing with this, but this is the air injection system in its entirety. Do what you need to do with that. I would say this, if you do take this off, keep these components for the next buyer of your bike, because if you modify your bike and make it a off-road competition use only bike, he may want to use it for street use, and so you can hand him these components where he can reconvert it back over to street use. So I would hang on to these, don't throw these out. Also, on your bikes, we have this vapor recovery system. And so the gas cap on your bike, if you follow it on your stock bike, has a hose that comes off, and then it splits to a Y, and it goes to a charcoal canister on your frame, in your frame. So if you have a 17 plus bike, you cannot see this, but on your frame, just under the triple clamp, you'll see these two little ports poking out of the side of your frame, and then you'll see the rubber hoses going up to a Y, and then that will go to your vent cap on your gas tank. And then down here on the bottom, there is a port that goes into this solenoid here, this little air valve, and that lives on the left-hand side of your engine by your left foot above the left primary sprocket, above the only primary sprocket, the drive sprocket on your bike. So these hoses, here's the Y, and then this would go up to the fuel tank, and then this goes here into the canister. And so this is what you have for your vapor recovery system. And so all our bikes are going to have this. And does this contribute to power of your bike? It absolutely does not. However, that said, the fuel vapors that get drawn, they're stored in this little charcoal canister. The fuel vapors in the startup sequence of your bike, the mapping of the US EPA map that's in your bike on a stock bike, accounts for the fact that there's a small amount of vapors that are drawn out of this in the startup sequence of your bike. And so when you start a US spec bike, the map has been derated just a bit in startup to account for the small extra volume of vapors that are coming out of this system. So if you remove this, startup on a stock bike might be a little bit more difficult. That is to say, it's a little leaner than it would have been with this system left on it. And so you might be needing to use the cold start knob on a deleted bike, whereas maybe you didn't before. And so that could be an inconvenience or a side effect of this, easily remedied by just popping out the cold start knob on your bike. So this system, again, does not myth that this removing any of this adds or takes away power. Having it takes away power, and that's 100% myth. It does none of that. Why would you consider removing this system? Well, there's a lot of individual components in this that could fail, and so if you remove this system, you remove a ton of failure points. And if you did have a failure point, let's say anywhere downstream, so how does this work? What happens here is you have this solenoid. This is just an air valve. This is like a sprinkler valve, you know, the solenoid on your sprinkler system. When this is energized, if you broke this apart, I should have brought that for the video, but if you break this apart, you'll see that there's nothing more complicated in here than the little plunger valve that is plunging, stopping, a stopper that's stopping up the air on this side. This side goes to the engine. This goes on the right-hand side of your intake, of your manifold, on the intake side, on the right-hand side of your engine, and there's a little brass barb fitting coming off of your cylinder head. This little guy plugs right in there. So when your engine is running, you're creating vacuum, and then that vacuum then is being turned on and off, cycled on and off with this little valve. And so the ECU, the computer, the map, is telling this thing to turn on, to open when you're in startup, and then at various times in the drive cycle, because it's purging out, it's cleaning out, it's vacuuming, sucking out any of the hydrocarbons that have been the vapors that have come off the tank and have been stored here, and those get sucked through this system and then burned in the engine. And so rather than have those just vent to ambient, they are stored and then used. And those hydrocarbons that come off of a fuel tank, a gas can, if you live anywhere in a state that requires a specific type of gas can, it's the same idea that those VOCs that come off of gas as it sits there, as it evaporates, those are pollution-causing components. VOCs, volatile organic compounds. And so this system is designed, and what it does is it captures those and then uses them. It recycles them into your motor. So when the computer, the ECU, tells this to turn on, that vacuum is then transferred through these hoses to the bottom port of your canister system, and then those vapors, which are just trapped in here, are sucked into the motor and they're burned. So that small amount of fuel, like I said, is taken into the startup sequence. So All of these hoses do that job. So what could fail on this? Well, I've seen these solenoids stick. If it's stuck closed, you would never know it. If it's stuck open, then you would have a continual vacuum through this canister, and that would change the fuel ratio of your bike. And so your map would be getting extra vapors and your bike would be running rich. And so there's some certain conditions, symptoms that would be going along with that if that was the case. If this thing were to, again, if it's stuck closed, you'd never know it, other than the fact that you might have that little bit of difficulty in the startup of your bike, that startup sequence, the fueling. If you had a leak in this hose, then you'd have a vacuum leak to ambient. And so now you're drawing in fresh air that the computer is not aware of, and so you're going to be lean. This vacuum leak here also may be drawing in dusty air. So you're drawing in fresh, dusty air into the engine, into the motor. And so that could be a problem. So a vacuum leak in a hose can create problems. And failures of these systems. I've seen these crack. And so if that happened, you'd be drawing in fresh air. So should you remove these things to remove that failure point? Absolutely. Again, myth to remove these because you're going to get more power. Not true. So how you would remove this system is, now this, let me tell you about this particular device right here. This is the KTM Hard Parts coolant bottle. And so if you wanted to, the space in your frame, the 17 plus, 17 through 20 plus, not 20 plus, but 17 through 20 bikes and beyond 20 all have this inside of their frame. The 12 through 16 bikes have this exact component, but its style is different. It's a round canister, and like the 12 through 14 bikes have that big bulb canister on the right-hand side of your motor under the gas tank. And so it's the same component, does the same job. You have all of this, it's just the style's a little bit different. So on those 17 plus bikes, if you remove the vapor recovery canister out of your frame, you're left with the cavity that you could fill with this. This is a KTM Hard Parts item, and it is a coolant recovery bottle. And so you can bring coolant, your off the top of your radiator cap, not your cap, but off the side port of the radiator under the cap is that little hose that otherwise just drains out to the ground. So if you overpressurize your system, the cooling system, that coolant, that extra coolant would just be wasted on the ground. But here with this little guy, down here is a plug because we're not drawing anything out of the bottom. We're just filling this up with coolant. And then one side of this will go to your radiator. The other side becomes a vent if you overfilled this thing just to drain. And so this little guy right here is a very clever use of that space. But this gives you a visual representation of what that canister looks like. Here's a bit of an overinflated myth. Guys will say, well, take this off because it will remove some weight. All of this combined is just a little bit over a pound or so. And so that's a water bottle in your backpack. So is this a weight concern? I guess it is, but that's a pretty weak argument. The real argument for this is that these things could all fail and cause you a breakdown or some drivability problems on the trail. So these systems, let me see if there's anything else to say about this. I think we've kind of covered it. On the stock bike, you have that difficult to remove gas cap. If you convert your gas cap, if you get an aftermarket gas tank, you're going to have a vent hose still, and I like and recommend one of those hoses that have the little check valve in them, so it's a one-way check valve. Oh, there's another failure point that could happen. On your stock gas cap, it has a little marble. If you shake it, there's a marble inside there, and that is designed so if you tip your bike over, the marble will come up and then plug the little vent port that goes into this thing and keeps raw gas from coming through the hoses and filling this up. And that's not super reliable. And if you tip your bike over, here's a problem that a lot of guys will have is with this stock system is they'll tip their bike over, it sits there, liquid gas is allowed to flow out of the gas cap into here, and so now you stand your bike up and you have liquid gas that has filled up a portion of this thing. And then when you start your bike and then the solenoid is commanded to open, you'll have strong vapors and liquid gasoline that will come out of this and then be drawn into the engine, and that will make it incredibly rich and sometimes cause your bike to not start. So guys will tip their bikes over and then they can't get them restarted. And if that ever happened, if you were on the trail, one simple solution to that would be you could find this little hose right here as it goes into your port, and you could kink it. So really quick way to do this is just kink this, crank your bike, get it started, and then once your bike is started, you can slowly release this, and as you do, see if your bike continues to run or stalls out. If it stalls out, then you can just kind of try it again, and then cycle this until finally you've sucked through the gas. Maybe keep the revs up a little bit and allow the liquid gas to be drawn in. Another thing you could do as sort of a trail side fix is you could just pull this off of that barb fitting, put your finger over that, or find some stopper, some way to plug that, and then just leave this off. Deal with it later when you get back home. But you have to plug that little barb, and in the Smog Delete kit that we have, we give you either a screw and a copper gasket, copper washer, to remove the barb if you want to. Now, just a quick word on that barb. I've seen guys break those barbs off. They're a little bit delicate. It's a brass barb with some Loctite into the aluminum head, and you need to heat that up. You do well to heat that up. And I've seen guys try to remove those and break them off, and now you're left with a broken off barb in the head, and you can remedy that by using some like Yamabond 4 Yamaha brand RTV sealant. Yamabond 4 does a very, very good job. Clean off that area really well, and then just put like a little dome of that and kind of shove it in there a little bit, and then plug that. You're going to plug that off with the Yamabond 4, and it does a very good job of that if you break it off. Some guys will drill that out and try to extract that. I don't recommend that. I'm not that good, actually. So I've Yamabonded them on some bikes when they break. When I've tried to fix bikes for guys, that happens. Or in the same kit, we also just give you a little rubber plug that you can put over that barb and not deal with removing it at all. Just plug it, put a stopper over that. So as a trail fix, you could figure out, jury rig some sort of stopper, and now you've eliminated this, and you can start your bike. If you also, another side word about this, if you live in a state where they're going to look for this stuff, you can leave all of this intact, remove this hose off the side of that little brass barb, plug that with a little stopper, and just leave everything completely intact. And if you needed to, you could then pop off the plug, pop this back on, go for your inspection. Now, anything that I mentioned by way of that may be illegal in your state, you take full responsibility for. By doing all these things, these are suggestions that I've heard guys use. Use them at your own discretion. So this vapor recovery system presents a ton of potential failure points. Removing all this eliminates that. Again, no power to be gained, but you do take away some failure points. So those are the two systems that we all have on our bikes, and what they do and why you might want to take them off. The last thing is not really part of the emissions, but it is part of the whole package that comes on a US bike, US spec bikes. These are all exclusive to the United States. You guys who live in Australia or other countries in the world don't have these. You may have your own specific types of systems, but they're not these. These are kind of exclusive to the US. And then the last thing would be intake reeds, intake pedals. I'll tell you why I have two here, on the intake boot of your bike. So if you've got a 17 plus US spec bike and you look under the air filter in the air boot, you'll see the backside, what you'll see is exactly this. And that is sitting in your air boot of your bike. And what this is this is an set of intake reed pedals, just like you'd have on a two-stroke. In fact, this same block is the same part number as the 300. This is off a 300, KTM 300. This is a stock set of reeds off 300. The only difference is the screw holes in the back of this one are now used because they're holding on this. This is the plate. This is the spacer. When you look at your stock bike, between the carburetor or the throttle body of a TPI bike and the engine side, you'll see this black spacer, and that is the holder for the reed pedals. So on your US spec bike, you have the same reed pedal. So why do you have this on a four-stroke bike? Well, there is a phenomenon that happens with a four-stroke engine that has, the more aggressive the camshaft that you have intake reversion. You have a pulse, a pressure pulse that happens in both the exhaust side, which is used, the exhaust side negative pressure pulse we have this little reed pedal over here, and that uses the scavenging effect to suck in the air. We talked about that. On the intake side, the same reversion, intake air reversion. What happens on the intake side is you get a back pulse of air that runs backwards through the intake of your bike, and then when the exhaust valve closed, you have all of that air rushing backwards, so you have an in and out rush of air on the intake side. And so what this does, Honda sort of pioneered this in the 80s with the XR500 bikes. They had a problem with the carbureted bikes. That intake reversion, that back and forth pulse of air on the intake side on a carburetor, the Venturi effect happens whether you're flowing air forwards or backwards. A carburetor doesn't know or care if the air is flowing in either direction. It can't detect that. It's going to create, the vacuum will suck up air from the carburetor. And so on those bikes and others, four-stroke bikes, the engineers decided, rather than taming down the camshaft, that's one way to solve this, is you just tame down the camshaft. You drop performance of the bike, and then you will reduce or eliminate that negative side effect. So the Honda engineers came up with a set of reed pedals that they put on the intake side of those bikes, and it worked really, really well. It stopped reversion. The other thing it does is it stops the disruption of that in and out air pulse in low throttle angles. So there is a point in the throttle sweep where these vacuum pulses go away, because now what you've done is once you get to a certain RPM, an engine is an air pump. All it's doing is it's sucking in air, it's combusting it, and pushing air out. So an engine is just an air cycle pump. It's a thermal air cycle pump. And so when this RPM, when you get the RPM high enough, what you've done is you've created enough airflow. Think of like a river, think of water flowing through a hose or a pipe. If it's low pressure, low volume, you might have this little water hammer situation, right, as you're turning on faucets in the house, and so you've got this little water spike. But now, if you have got full flow, high RPM, you have so much air flowing into the intake stream that these little small pulses no longer are small. They're actually a huge amount of air in transit through the system, and that phenomenon goes away. And so this is really designed and installed to like factor out or to scrub off those negative pressure pulses at those low throttle angles, those low RPMs. So this on your bike aids in throttle response and power at low throttle settings. And so as a rule of thumb, we leave these on bikes that are trail bikes, like hard enduro bikes, machines that are used for low throttle, like guys who spend most of their life, and this is a big majority of riders, a ton of riders spend all of their, not all, but most of their moto career at throttle angles from like idle 0 up to maybe 30 or 40%. And they only seldom, if ever, get in the high throttle angles, wide open, if ever, very occasionally. And so depending on where you spend most of your throttle, you may want to leave these in, because these do improve and make a significant difference to the throttle response and power delivery at lower throttle angles. So internet mechanics, though, will often just bristle and tell you, get these out every bike, every time. And that's fine if you want to do that, because there is a valid concern with this in the fact that these are reed pedals and they could break. And if they break, just like on a two-stroke bike. Now, here's a counter argument to that. On a four-stroke, the auto cycle four-stroke engine, you only have a power pulse every other rotation of the crankshaft. On a two-stroke engine, a two-cycle engine, it's twice as many. Every single piston cycle is a power stroke. And so on a two-stroke, this is opening and closing every cycle, half as often, so 50% or 100% less cycling on a four-stroke engine. This does half the work. It gets half the wear on a four-stroke engine that it does on a two-stroke. But nobody ever really worries about the durability of these on a two-stroke engine. Now, it is a potential failure point on it, but it's also a maintenance item. You should look at these, you should inspect these, and these should be replaced on a two-stroke. And the same thing holds true on a four-stroke as well. These are running only half as often opening, and so these are going to last a ton longer. There are reports out there that these have broken, and I've read reports and heard reports of guys who have these fail on two strokes. And if that happens, this little fiberglass thing is designed, sometimes these are carbon fiber or fiberglass, these things are sort of designed to sort of disintegrate. If these get drawn into your motor, very, very often, nobody even knew that. If it's on a two-stroke bike, your bike just either dies or the performance is really off, the power is off, and then you start investigating, you discover these have broken or frayed at the ends, and then you replace it. Very, very seldom do you ever hear any reports of engine damage. So those are overinflated. And so this becomes just a visual inspection component on your bike. So if you are a wide open rider, if you're a supermoto guy, a flat track guy, a wide open desert race guy, or you spend a good amount of your time at higher throttle settings, then it would be a good idea to remove these, because this is an air restriction. You have a essentially like an intake obstruction here, and then these pedals have to cycle open and close, and so all of this combined together does create an air restriction. So that is valid. Whether or not you should leave these in is really up to the discretion of each rider. I do not have a hard and fast rule. I do not tell every rider to leave them in, nor do I tell every rider to take them out. We look at each bike and each rider and each use of each bike and specifically sort of create a prescription or a recommendation on what that guy might want to do to that bike. And so, again, based on who you are and how you ride your bike, leave them in, take them out. It does matter, in both ways. There are, as with everything in life, everything is a trade-off. Anything you do or don't do creates a cascade effect, a side effect, intended and unintended consequences. And so, doing anything will have a result, a net result. There will be a consequence. And so, figuring out what your goal is, what you want to accomplish with your bike, what you're after, and then doing the things that promote that exact outcome is the right thing to do. That's what you want to do. Just watching internet mechanics or reading posts and then doing what the keyboard mechanics tell you to do, that will produce a result. Who knows if that's going to be a result you're happy with or the result you want. So that's it. So this is the overview video of all these emission systems. Again, these reed pedals are not part of the emission system. They do something else. So this also, I guess the other thing this does is this obstructs the intake noise through the motor of that valve overlap. So that throaty, deep intake sound that happens, this scrubs that off. You know, there's another, I guess we'll have to make another video about this. There is a thing called the Helmholtz resonator that a lot of, well, so a car will have a thing on it. This is a quick detour, a quick aside. Look at the intake tract of your car, and you'll often see these very strange, very curious little bulbs or dead-ended angles, these pieces of hose. So you've got your plastic form intake runner from your air filter to your throttle body, and then you'll see these weird little, sometimes they're 90-degree angles, sometimes they're like little, not corkscrews, but just these little offshoots of that seem to do nothing or go nowhere. Those are tuned resonators that dampen both the back pulse and then the sound, the intake sound that comes out of your motor, and that is a Helmholtz resonator. Research that, figure out what that is. Guys who modify or take those off on their cars find that they do not get what they're after. They were thinking they would get increased performance by taking those off, and very, very often they find that certain RPM ranges, certain throttle openings, they will reduce the power. And so the guys who work on this stuff and design this stuff, they're doing it because they're smart and they know what the hell they're doing most often, or in some instances they're being told to do a thing. For example, these two emission systems that we first talked about, those are EPA mandated in the US. So some of this stuff they're being asked to put on, and some of it they're putting on because they're pretty clever and they know what's up. And so when you take off those Helmholtz resonators on your car, your automobile, you're going backwards. Whatever you hope you're gaining, you're probably losing. And when you automatically, by default, take these off, whatever you hope you're gaining, you might be losing, and you might have made a mistake. So again, you just have to look at what each of these things are and really decide through good engineering evaluation if you should leave them on or take them off. Internet mechanics all have their opinions, but real mechanics can guide you through some of the selection and thought processes that go behind tuning your bike, setting up your bike, and building your bike for the exact kind of use you're going to have with your machine. So that's it. Leave your comments. If you have any questions, let us know. If we made any mistakes or said anything wrong, please let us know. We're not afraid of your comments. And we leave comments turned on all our videos because we want that give and take. We want that feedback. And if you have any questions, you can email us, mike@tacomoto.co, mike@tacomoto.co. Happy riding. Thanks for watching. Go out and get some adventure.